Hello, students. Now, till now, what we have seen, what is the building block of our neural network? That is a neuron or perceptron. How we can arrange perceptron in layers? What is a single layer perceptron? What is neural network containing multiple layers of perceptron? That is what the artificial neural network. Now, today's video, we are going to see how we can judge the accuracy of our artificial neural network. Now, to judge the accuracy of artificial neural network, we have to find out cost function. And to reduce this cost function, the technique we are using is the gradient checking. Now, what do you mean by cost function? Now, cost function is a parameter. It is represented by a formula and it is used to judge our model. Means how correctly our model is working, how accurately it is predicting data if we are using our neural network for prediction. Means, listen, what we are doing in our artificial neural network, you will supply one input data set, then you will assign some weights, you will get the weighted sum, then you will add bias to it, then you will apply your activation function and you will get some output. Now, input you are transferring to output. But what is this output? This is the obtained output. Now, there is some expected output. So, the difference between these two will be called as a error. And that error we want to lower. Means we want very low value of that error. Means how correctly your model is trying to establish the relationship between the input and output. How well it is modeling the relationship between input and output, that we are going to judge by using the cost function. Okay, means how correct is our model and in which cases our model is wrong. That also we can find out using the cost function. So the cost function is used to optimize your model. Okay, that is the best values for your weights to get more and more accuracy, to get the correct fitting of the data. Now, let us see one example. There is one robo. That robo is picking box from one place and it is putting it in another place. Now, there may be some obstacle in the journey of the robo. Okay. Now, we know that when robo is moving boxes from one place to another place in a hall, then he may get something that he don't want to move. It may be a rock also. Okay. Now, so based on the structure of rock or based on the features of rock, we will train the robot that when next time rock will come in between, either you change your path or don't move the rock. But we have not at all expected that there will be fire in the room. And whenever fire is there, what action robo should take, that we have not trained. Then in such cases, how your robo is performing, how your model of robo is working, how your training will work in such a situation. That is what the cost function is telling you. Now, what is the cost function for neural network? Our neural network is taking multiple inputs. It will run through some algorithm and it will generate the output, okay, to get the final output. Now, listen, our neural network is moving in between the layers. Yes or no? In between your input and output layer, there are many hidden layers. Now, at each neuron of this layer, there will be some error. Okay. Now, collecting errors from all the neurons in that layer, we will get a sum. So that sum becomes a cost function of that layer. And finally, the total sum will become the cost function of your neural network. Okay. Now, while finding the error, we should find out the error at each layer, starting from your first layer to last layer. And then we have to sum the individual error. So how we should represent such cost function? Now listen, there is a input 1, 2 and 3. Now we are applying some algorithm. Then you will get the error 1 in first input, error 2 in second input, and error 3 in third input. Then you have to submit. Okay. So this is what the error in your input layer only. So such a way there will be many layers. Then that will give you the cost function. The overall sum of errors will give you the cost function. Now what is mx? That is your weighted sum. Then you are adding the bias to it. So this is what your generated output. Now y is my expected output. The difference between y and generated output means the difference between the actual output and generated output is known as error. Now what I am doing, I am taking the square of that error. Where I am taking the square of that error, here you can see. And again, I am taking the mean of it. So what this parameter is indicating, MSE. That is what the mean square error. So our cost function may be represented by mean square error or mean absolute error or root mean square error. So these are the different kinds of cost function to indicate the accuracy of your neural network. Now here, the terms that you should know is minima and maxima, and that minima and maxima is applicable for local level as well as global level. Now let us see what do you mean by it. Okay. Now, first let me see. Now, local minima means what? It will compare the minimum value with the preceding point and succeeding point. Means in those surrounding layers only, whatever is the minimum, that is the local minima. But global minima means what? It should be minimum in all the layers. Okay. Now in one layer, we are having many neurons. So the minimum error for any particular neuron will be the local minima. But that is only for that one layer. But such many layers are there. And out of these all layers, whatever is the minimum error value, that is called as a global minima. Okay. Now here, you can see that we want to find out local minima and mainly global minima to reduce the error. Okay. Now see, minimum value of all local minima is the global minima. Okay. Now, so gradient descent we are using to find out that local minima or global minima, so that our cost function will be reduced. So what the local minima or global minima is indicating the minimum error. Now what is our target? To reduce the error as much as we can, so that the accuracy of our model will be more and more. It should reach up to 100% also. So how it is possible? You by reducing your cost function. So you have to reduce the cost function means what? First you should reduce the local minima and you should reduce the global minima. So who is useful in that case? Gradient descent is useful in that case. Now how it will work? Now let us see one example for understanding the gradient descent. Now listen. One scenario, a person is stuck in mountains and he is trying to get down. Directly, he will not jump from the top of the mountain to the ground. What he will do? First, he will find out the topmost point from where he can get down. Then again, he will find out the next point with more slope. The next point. So like that, he will come to the ground. So that is what the gradient descent means. First, you have to find out the local minima. Then you have to find out the global minima. So you are trying to get from top of the mountain to the ground using the steepest descent. Okay. And now another example. When a person want to reach to the bottom of the sea directly in one jump from the ground to the bottom of the sea, he will not reach. Slowly he has to move. Means the steepest descent curve he has to take. Okay. So that is what we are doing in gradient descent. Now, what we have to do is we have to pick an initial point. Okay. And to this initial point, I am subtracting what I am subtracting the gradient function that I am subtracting. But that gradient function should be multiplied by learning rate. Okay. Means alpha t means what? The learning rate at tth step size. And what is your derivative function xt stands for? That is a gradient of a function. That is a collection of partial derivatives into a vector. Means what you are trying to do here is step by step. Means first find out the local minima and then try to compare with the other local minima. Then whichever is minimum, that you will select. So like this, you are trying to find out the global minima. So that is what the gradient descent is trying to achieve. Okay. So when you are getting a new x value, that is the value should be used at the t plus 1 step. So that concept is known as a convergence. And this is what the main formula used for your gradient descent algorithm. Okay. Now when you will stop, by using the new x value, that is the x value at next timestamp, you should see what is your output. If that output is giving you the error that is less than the threshold, then you have reached at correct point. Then at that point, you can stop. Okay. So what are the applications of this gradient descent algorithm? It is used to solve linear equations and even it is capable of solving non-linear equations also. Now it is capable of running in infinite dimensions. Okay. And it can be combined with the line search algorithm. So this is all about what do you mean by cost function, then how you are making use of local minima and global minima, and how you are trying to reduce the error using gradient descent. Thank you.